For years, artificial intelligence has served as a capable but passive assistant. It could draft a polite response to a client or summarize a complex report, but it always stopped and waited for a person to click approve. We are moving past that boundary. The newest generation of AI doesn't just suggest content. It observes its environment, formulates multi-step plans, and uses digital tools on its own to reach a goal. This diagram illustrates the mechanics of that autonomy. When you give an agent a single objective, it breaks it down into individual tasks and navigates across your CRM, ERP, and payment systems to complete the sequence. This marks the transition from a read-only tool into a system with write access to the real world. Granting software the authority to act independently inside a production environment creates a new category of vulnerability: execution risk. If a traditional language model hallucinates, you get a bad email draft. If an autonomous agent hallucinates, it triggers a concrete failure. We can map this damage through the blast radius concept. Imagine an agent tasked with optimizing server storage. It identifies old data and deletes those records to save space, not realizing it just wiped out legally protected compliance logs. Because agents execute these actions at machine speed, the traditional window for a person to spot an anomaly and intervene has shrunk from minutes to mere seconds. When the consequences of a mistake are immediate and irreversible, unchecked autonomy becomes an unacceptable operational liability. Many organizations attempt to mitigate this by simply placing a human at the end of the workflow to monitor the output. They call the system safe because a person is present, but high reliability often leads to automation complacency. As a system proves itself dependable over time, human operators naturally lower their vigilance and stop questioning the machine's decisions. The aviation industry encountered this problem decades ago. Airlines discovered that pilots who were only required to passively monitor automated flight systems were unable to react effectively when those systems failed. This Air Canada flight simulator represents the solution they developed. Pilots are forced into rigorous physical training to practice actively challenging automated systems under pressure. True oversight is a trained operational discipline. It cannot be achieved through passive observation alone. Effective human-in-the-loop oversight is a deliberate architectural requirement engineered directly into the system's code. The core of this architecture is the pause mechanic. The system is programmed to natively halt an agent's workflow before a high-stakes action. During this pause, a secure handoff protocol routes the context and expected blast radius to an authorized human gatekeeper. This model scales based on risk. For high-volume, low-stakes tasks, like routing internal IT tickets, the system can run with full autonomy. Medium-risk tasks use a human-on-the-loop model. The agent acts, but supervisors actively monitor outcomes through dashboards to roll back any anomalies. However, high-risk actions remain human-in-the-loop, requiring explicit human authorization before the agent can proceed. This architecture ensures the level of human friction always matches the potential impact of the decision. There is a fundamental limitation that makes this pause necessary: the context gap. An AI agent can parse vast data sets with incredible speed, but it lacks an understanding of business ethics, long-term strategy, and legal nuance. This 2026 industry report highlights that the bottleneck for agentic AI is no longer model quality, but the maturity of the governance surrounding it. Regulators are already addressing this, with the EU AI Act legally mandating human oversight for high-risk systems. An algorithm cannot hold financial liability or face legal penalties. A human is required to supply the judgment that math alone cannot generate. By getting this architecture right, the workforce moves away from executing manual tasks and becomes a team of strategic commanders. This is the peak of human AI orchestration: human workers managing fleets of autonomous agents and intervening only where complex judgment is essential. Organizations that ignore these guardrails in favor of unchecked autonomy will face catastrophic operational failures and regulatory sanctions. Realizing the potential of agentic AI means anchoring the speed of machine execution to the bedrock of human accountability.